We're given the curves f of x and g of x intersect at the point 1, 6, this point here. We want to find the angle of intersection in radians. The angle of intersection of two curves is equal to the angle between the tangent lines to the curves at the point of intersection. So we'll begin by determining the slope of the tangent lines to the two curves at this point. So we'll find the derivatives of both functions and evaluate them at the point 1, 6. So notice f prime of x would be equal to 2x plus 1, and therefore f prime of 1 would give us the slope of the tangent line to the blue curve at this point, which would be 2 times 1 plus 1, which is equal to 3. So the slope of the tangent line to this blue curve at the point of intersection is positive 3. And now here's g of x, so let's find g prime of x. Notice g prime of x would be a constant because g of x is a linear function. G prime of x equals negative 5, and therefore, of course, g prime of 1 is also negative 5. So the linear function has a tangent line with a slope of negative 5 at this point of intersection, which should make sense because this line is its own tangent line and it has a slope of negative 5. Now for the next step, let's go ahead and sketch the tangent line to the blue function at this point. Here it is graphed in green, and now we'll use vectors to find the angle of intersection between these two curves. We'll find a vector that has the same slope as this green tangent line, let's say this vector here, and then we'll find a vector that has the same slope as the red tangent line, let's say here. If we find the angle between these two vectors, using this formula here, this would be angle theta, which would be the angle of intersection of the two curves at this point of intersection. But notice how this angle theta would be an obtuse angle of intersection. So if our directions did say find the acute angle of intersection, we'd actually have to find this angle here, which should be pi radians minus theta. But again, since we now know that f prime of 1, the slope of this green tangent line here, is equal to positive 3, let's call vector A the vector that has the same slope as this tangent line, and we could use an x component of 1 and a y component of 3. And then because we know g prime of 1 is equal to negative 5, for the second vector here, let's call it vector B, we'll use an x component of 1 and a y component of negative 5. Let's take a moment and sketch these two vectors with their initial points at the origin on this coordinate plane here. Vector A would be this vector here, and vector B would be this vector here. So the angle between these two vectors, this angle here, this theta, is the same angle theta we see in this graph. Let's go ahead and find that angle. Cosine theta would be equal to the dot product of vector A and B divided by the product of their magnitudes. So vector A dotted with vector B divided by the magnitude of vector A times the magnitude of vector B. So here we'd have the square root of 1 squared plus 3 squared plus the square root of 1 squared plus negative 5 squared. So we'd have cosine theta is equal to, for the dot product, we would have 1 times 1 plus 3 times negative 5, that would be negative 14, divided by, here we'll have the square root of 10 times the square root of 26. So we have negative 14 divided by the square root of 260. This does simplify, but there's no reason to, since our goal is just to find theta. We now know that cosine theta is equal to negative 14 divided by the square root of 260. Let's find theta on the next slide. To solve this for theta, we would take arc cosine of both sides of the equation, which would give us theta is equal to arc cosine of negative 14 divided by the square root of 260. And now we'll go to the calculator to get our decimal approximation for theta. We first want to make sure we are in radian mode, so we'll press the mode key. We are in radian mode. Go back to the home screen. And now we'll press second cosine for arc cosine or inverse cosine. And we have negative 14 divided by the square root of 260. Right arrow, close parenthesis, and enter. So this gives us theta is approximately 2.6224 radians. So if we go back to our sketch again, we found this obtuse angle here as approximately 2.6224 radians. So if we wanted to find the acute angle of intersection here, we'd have to take pi radians and subtract theta. Let's also find that angle as well. So let's call this theta sub 1. We'll say theta sub 2 would be approximately pi radians minus 2.6224. Let's go back to the calculator one more time. So we have pi radians minus 2.6224, which would be approximately 0.5192 radians. So depending on your text definition of an angle of intersection between two curves at a point, you may be expected to find one of these two angles. I hope you found this helpful.